Sorry about that. Oh, apparently I was muted. Yes, so there's been various of these cloud operating systems. Mostly they're like, for example, the OCaml people have this thing called Mirage, which is absolutely great because it means you can run a completely OCaml system as a VM all by itself. And it's absolutely marvelous if you like OCaml, and if you don't want to write your whole program in OCaml, then it's not really for you. Some people involved with NetBSD have done something much more interesting. What they've done is they've sawn, they call it rump kernels, they've sawn the VM system off of NetBSD and the system call layer, and they've turned NetBSD, the kernel, into a library, which you can link against the NetBSD libc, and now you can sort of compile your program and link it all into a single address space image and run it on various things. They've got a Xen thing that you can run the programs on. They've got one that they call POSIX, which lets you run it as a process, sort of a bit like UML, only it really is a single process. It's got no scheduler, nothing like that. So this is quite good because this means you can take allegedly normal programs and compile them for this environment. But their build system is a bit bad. And even if their build system wasn't a bit bad, it poses certain problems. So now we get on to our nice Debian world. So here's a nice diagram of some packages. You know, you have some source packages. I've not shown all the build dependencies because there's going to be no room on this slide. So we've got some packages. You tend to have some kind of, maybe you get it from Git, maybe you have an upstream tarball, you add some Debian files to it, and you build it and it produces a .deb. So that's all very nice. And this is what I now need to do. So you will notice that I have got Xen in this 3 times. So the Xen upstream source code has to be used 3 times in this build process. We need to build it once in the normal way to generate the actual hypervisor and all the things that people are expecting. And that build, at the moment it doesn't. Yes? No.
Light on it now. Yes? Okay, thank you. Did you already tell us what's the problem you're trying to solve?
Yes.
And what, I missed that.
What I'm trying to produce is I'm trying to build these NetBSD rump kernel programs in Xen because we want to make we want to use the Xen the rump kernel thing that the NetBSD people have done to run parts of the Debian tool stack and its support software in VMs.
Yes, and you want to do it the Debian way.
Well, ideally, before I bake too much of my build system in stone, I'd like some advice on what it would be nice for this all to look like.
Okay.
So what I've got here is boxes, and the round boxes are packages that sort of mostly already exist, and the square boxes are things that don't have a place to live at the moment. You know, I have a working directory on my computer that contains stuff, but exactly how this should be put into something like a Debian archive is less clear. So yes, so the ultimate goal is, for example, we've got a thing called pygrub. Let's take pygrub because that's a nice easy one. The top right corner. So at the moment, most people using Xen use a thing called pygrub, which is a sort of half-assed emulation of grub 1, grub 2, Lilo, syslinux, anything else that anybody decided to put parsing code in it for. It's written in Python. It links to libfsimage, which you may or may not have heard of, which is a collection of file system drivers in user space. And this runs in your master control domain, that is your host VM, looks into the guest's file system, finds the kernel according to, it may even put up, it can even display menus, and then passes that. It finds the kernel and passes it to the rest of the system for actually booting the guest. And this is not ideal because if your file system driver has some kind of bug, then that's a security vulnerability. There are also other reasons why it's kind of not ideal. The console handling of this weird extra process that's not running in a guest is a bit messed up, or at least complicated. Now, PV-grub 2 is going to solve all these problems sometime in the next decade. But in the meantime, I'd like to do a stopgap solution, which is, well, we'll build Python for NetBSD rump kernels, and then we can run pygrub as a VM. And we'll grant that VM access to the guest's file system, but it doesn't need any other privilege. It provides the kernel to the tool stack, and yeah. So you see I've got this rump Xen libs and tools here. This is a combination of an enormous pile of NetBSD source code, some of which is rump kernel specific, but most of which isn't. It's basically just NetBSD. So you see I've got 64 megabytes of .git directory. I did this du the other day. If you unpack that, it's a third of a gigabyte source tree. You build that against some of the outputs that you get from the Xen build system, or at least some of the outputs that you would get from the Xen build system if it bothered to ship them. And then you get, well, a bunch of .a files. It's all asynchronous, very confusing. A bunch of .a files, a bunch of headers, a weird compiler wrapper script, a specs file for GCC, that kind of thing. Not a proper cross-build environment. We don't want to rebuild GCC because we're just targeting the native CPU here, but we need a completely different symbol namespace, maybe some different compiler options, things like that. So then you use that wrapper script to run Python's configure. But of course, you can't really, you can't do this in a Python tree that you're also building the normal way because it's a different environment. It's a bit like a cross-build. As far as configure is concerned, it is a cross-build because the executables that come out of this process are Xen guest images and can't be run as executables. So configure can't run them. So technically then, yes, it's a cross-build. And then, of course, we need to mix that up with the pieces of pygrub itself that came out of Xen. Now, things get even worse with one of our other principal targets, which is qemu. QEMU is used in Xen systems to emulate a PC. If you have a fully virtualized guest, it needs an emulated PC, and we use QEMU for that, like everybody does. If your QEMU has a security vulnerability in it, then that's a vulnerability in the whole system, at least if you run any HEM guests. We don't like this, so for a long time we've had a thing called, we call it stub domains, but basically you run your QEMU in a domain of its own. It has privilege to access the memory of the guest, but it doesn't have privilege with respect to the whole system. So if the guest has some kind of, it has some kind of trickery and it takes over its own QEMU, then, well, fine, that QEMU can't do anything that the guest couldn't have done itself anyway. So, yeah, good luck with that. Great. Unfortunately, the version of QEMU that we have managed to do this to is a decade-old fork. I'm not sure it's even in Debian still. There is, since then, the upstream QEMU community have rushed off and become a hive of activity, and they do all sorts of much better, cooler things now, and it's much less crazy. And now I want to cross-build that. In order to cross-build a QEMU that can do all the hardware servicing for a Xen domain, that QEMU needs to be linked against a pile of libraries that come out of the Xen toolstack libraries, special functions for accessing the memory of other domains and manipulating them in various ways, IPC and interdomain communication mechanisms. And those are all in Xen.git. But of course, we don't want a standard build of Xen.git. Those libraries, if you just build them in the normal way, are built for your local operating system. Whereas what we actually want is want them built against this NetBSD thing. So now we're going to have to build Xen.git, again using this weird wrapper script. So you run the weird wrapper script, Xen's configure, notices it's cross-compiling, you get a subset of the build deliverables out of your build, and then you have some .a files which go together with these .a files and some include files, and then you can run QEMU's configure against the two things together, and it's almost like you're setting up a little parallel cross world. Okay, so I'm going to stop hand-waving now about this diagram and start hand-waving about what might be done. So that somehow the most official or kind of formal way of doing this would be to say, well, these NetBSD rump kernels are they're very like an architecture. You run configure, you run make, they produce deliverables. So we'll call them an architecture. So that means you have a rump kernel AMD64, a rump kernel i386, a rump kernel ARM, a rump kernel ARM64, and so that's 4 architectures. They'd be partial architectures because only a tiny subset of the archive would be built. Here we go again. And all of this infrastructure with 4 additional architectures in the archive would exist only really for the benefit of Xen, which is itself just one tiny thing in the Xen in the whole Debian ecosystem. So I don't think that's really a sensible thing to do. So another thing I thought was, so that's obviously not on. If I were to try to do that, people would hate me. I'd probably hate myself as well, so I'm not going to do that. So on the other end of the scale, it occurred to me that I could cause the Xen.git package to produce a copy of its source code as a source deb, and I could probably even persuade the QEMU people and maybe the Python people to do the same thing. And then I could have some package that had all of this and a giant nightmare build script, and that just, by hand did all of this stuff. And it would be sort of a bit like IA32 libs, in that any time you wanted to add a new one of these, you'd have to go and find the original packages, and there might be a whole stack, right? I haven't got as far as compiling Python yet. I've been working on QEMU, but I imagine that in order to get Python to work, there'll be a bunch of libraries I have to do first. So I have to go to each of those libraries and persuade them to produce one of these source packages, and then add them to my giant build the world thing. Yes?
And you really, am I on? Yes. And you really want it to be in the Debian archive, all of it? Well, what I want to be in the Debian archive is this file. Because this file, right, as far as the user is concerned, this file is a piece of the infrastructure for the Xen system. And it should be used, actually this should be used by default. You shouldn't be using your host compiled QEMU by default, you should be using this, because it's more secure.
So all of this infrastructure is just there to produce this deliverable, which dumps on the user system in user lib Xen never heard of it type place, and the tools automatically pick it up, and the user is completely oblivious of all of this. So that's one reason I want it in the archive. But once you start doing this kind of thing, the next thing that happen is the user will say, "Oh wow, cool! Does that mean I can write, I can write Python scripts and have them run in Xen directly?" So now they want this Python rump image, and they want to be able to meld it with their own, Python scripts, which means that the tools that probably live in here that manage the file system image that this domain runs on also want to be delivered to the user. Of course, those are all BSD FFS. So we're going to, the part of this is I'm sort of taking a whole operating system and saying, this whole operating system is just, we're going to package it up neatly in a little package with not too many tentacles and bury it in Debian. You were first.
So I've got pretty much the same kind of problem with Windows cross compilers. So the aim of the Windows cross toolchain is to end up with, same as you with your QDM image that ends up in the Debian archive. We use the Windows cross compilers to build Windows executables that end up in Debian installer, and a bunch of DLLs that end up in WineGecko that's used for wine. And like you say, once you start doing that, there are other people who say, oh, it'd be really nice to have all these libraries that we could use with the cross compiler for Windows, and then you end up with the same kind of problem, asking people to produce source debs, but then you get pushback from the other Debian maintainers, which is perfectly sensible, and they say this only makes sense if we add it as a proper Debian architecture, and then everything just sort of falls out automatically with configure and so on, because you just get the triplet and it all works. But if you don't do that, it's a nightmare amount of work with all the source packages that need to be used, and you either do it on the side somewhere and then you can't get it in the Debian archive, or you do it properly.
It's tempting to suggest that you could, rather than making everybody ship source debs, you could, from the bottom up, for each Linux architecture pair for the NetBSD thing that you're trying to produce, build a binary package which is labeled architecture AMD64, but is in fact contains NetBSD AMD64 stuff off in some path that nobody cares about, and you could deal with fixing up the paths in your build system. That would at least let you get the binary objects into the archive, and your top-level build could just produce qemu DM, but at least then you'd be able to have build dependencies for sensible-ish things.
Right, so what you're suggesting is that Python should be the real main Python package should be changed to produce these rump-Xen AMD64 libraries and things off in a separate path.
Something like that in separate binary packages.
Right.
I've absolutely no idea what
that makes Python build depend on this.
Yes, it does. Alternatively, you could, you don't necessarily have to have everything work the same way. You could have a Python Xen separate source package which you occasionally resync, but have other packages which are less, complex and intertwined than Python do those binary packages directly.
Right. So.
But that means convincing all the maintainers to take all that on. Another approach would be
Unless you do the -Xen source package thing.
Yeah. Right. But yeah, with the other libraries, the other library side that you want to build grump-Xen binaries, that would mean convincing their maintainers to take that on. The other approach, which you've mentioned on the mailing list already, would be source build dependencies.
I commented on source build dependencies at the last DebConf, and I'm not sure I managed to convince Walter that this was legitimate. But I don't, given that every package already requires to be able to fetch its own source as part of its build process, I don't see why you can't legitimately do apt-get source in a packages build, stick it somewhere in your builds tree, and then do that. You don't need to invent infrastructure for source build dependencies to make this work. In the worst case, you need to fix a couple of firewalls and build these or something. But there's no reason why you can't just.
What you're suggesting, having Debian rules call apt-get source?
Yes. People have a sort of, some people appear to have a visceral reaction to this, but I don't see why it is illegitimate.
It is allowed by the building policy called apt-get. It's not allowed to make arbitrary network calls.
Right, and apt-get source is obviously quite different from calling apt-get install. It just fiddles with your current directory state.
Boggle. That would certainly make all of this a lot easier. You could make a little Python Xen package that you could generate these little stub packages that would go, well, I'll just get the Python source and I'll mess with its build system slightly, put my weird compiler on the path, and then I'll just build it. It'll all be fine.
And you would want to make sure that you're getting the versions you expect or something, but you might need sanity checks on all sorts of things. But it doesn't seem fundamentally very difficult.
Right. I'm going to put in a built using then, am I?
Yes. That matches the built using semantics precisely.
This is a novel and radical suggestion.
Thank you, Minister.
I'm very surprised to find you proposing it, because the idea that the package build should go off and fetch stuff from somewhere.
So
traditionally we've done that in places like sbuild and not in the rules file.
Indeed.
And it's not declarative either.
It is indeed not. I'm certainly more comfortable with other things like, so I think things like partial architectures are a much more elegant approach to this. They're also a ton more infrastructure to stand up. So.
Right.
So I'm suggesting this not as a particularly elegant thing, but as something that, as far as I can see, should work today without having to build up a load of stuff.
I guess if I do that, then having deployed it, it will be very easy to persuade people that there should be some better infrastructure for source package dependencies.
This was true of IO32 libs too, and look how long that took, but yes.
Yeah, it might be hard to get it through you now.
Do we have anybody from the FTP team here?
Physically, they're not in the room. There are people.
Are they listening to the stream?
There's a couple of FTP assistants here. You can corner over one as well.
Right, well, maybe we should do that. Yes.
So we've talked about partial architectures a lot over the years, but nobody's ever really got very far with them, at least not in the Debian archive. Is the main blocker simply working out how we do a build D that doesn't actually try to build everything as is usual? How do you mean? Depackage has a Windows architecture element, doesn't it, somewhere? I've seen it in triplet table, I'm sure.
Well, the whole thing would be a cross build.
Well,
right?
yeah, the main blocker for me anyway is getting the patch that provides the Windows triplet as an architecture into Depackage. So it means convincing qemu. That's for now.
So I was going to say that in terms of actually getting partial architectures off the ground, one of the things that I think has always been a de facto blocker is we talk in general terms about how we could do this, but I think somebody needs to come up with a concrete proposal and show that, yes, if we did this, this is the set of packages that would make sense to build and why, and we have a buildable closed set that it's useful to do this for that's less than the architecture and has some sort of a policy around it which isn't altogether arbitrary. And I think if we had something defined like that, then you're right, we would need to have the implementation of the builder as well, but that yeah, it's not going to move until somebody puts together a more fleshed out proposal.
The closedness of the set is, of course, much easier when cross-building, so perhaps this winds up effectively blocked on build profiles so that we have that more official. But you know, most of the binaries we need presumably, in fact, come from some other architecture because you're using them as multi-arch foreign things and cross-building.
Right. I mean, if you did this as a partial architecture, I imagine it would be like a little multi-arch stub thing. But you'd have to make sure that nobody thought it was a good idea to install the Python rumpxen AMD64.deb is not really usable as for satisfying multi-arch cross dependencies.
Well, this is Python NetBSD ARM64, isn't it? Or NetBSD something. Is that right?
Well, it's the thing, the actual Python file that's got the Python code in it isn't, okay, it's an ELF, but it's a compressed ELF kernel. And to execute it, you feed it to the Xen tool stack as a kernel image, and you can't use it to run Python scripts on the host.
Right. So that is then not a Python 2.7.deb. That is Python 2.7-stubdom or something .deb. It has different semantics. It deserves a different package name regardless of what you do. Presumably this would be not too terrible for the Python maintainers since they wouldn't actually build this normally. It would be a thing in their control file with an architecture field that caused it not to actually be built for anything useful.
Right. I worry, though, about wrinkles. So we've got here the other examples that we might want to do some cross builds for, well, Windows, maybe Wine, or whatever. It's likely that this also would require some violence done to the upstream source code. I'm not expecting to be able to compile Python unmodified. It's possible. In principle, it should just work, but there's going to be some bugs, and some of them are going to be bugs in Python that I will try to fix upstream, but there's always a lag with that, and some of them will be bugs in this whole rump setup. Well, when I say bugs, infelicities, ways in which that it's not like a real system, and there'll have to be some bodge.
This is where I think Debian ports can come in handy, because in Debian ports you're allowed to carry packages from the main archive with your extra patches until they get merged upstream or merged into the main Debian package.
That's an excellent idea. All I need to do then is to depend on something, is to have your main Xen hypervisor get me all my stuff.deb meta package just needs to depend on the relevant package from ports, and nothing can possibly go wrong.
Then you try to get this into testing.
Yeah, right. Exactly.
Are all of these binaries that you're trying to build only useful on a already AMD64 Arch install, or do they are you aiming to have these packages, these new ones that you're building, be usable without the rest of the Linux host architecture?
Well, okay, so in principle, supposing herd were ported to Xen and could be a Xen DOM node. In principle, the same Python rump Xen AMD64 libraries, executables, etc. would do for the herd as would do for Linux. And actually, the build system for this stuff doesn't involve the host libc. And so doesn't involve the host kernel headers. It involves NetBSD kernel headers, which are supplied here at the bottom left. And it gets more confusing than that because if for some reason you're running an i386 DOM node rather than an AMD64 DOM node, there are a couple of reasons why you might be doing that, you probably still want to be running an AMD64 rump Xen PV stub images. So probably we only want rump Xen AMD64 and not rump Xen i386, and the i386 users will be using AMD64 packages, and that works. That can work at the moment because, as I understand it, the GCC that's in Debian i386 can generate AMD64 code. It just doesn't come necessarily with a libc, but I've got a libc. That's fine. So far, add get source in the rules file is the most promising suggestion here, or go around all the packages persuading them to produce a source package deb.
One other option that you could consider that would probably be a lot of work would be to have your rump Xen dash every one of the packages that you actually want to be available here under each one of the architectures, which is kind of like what Fedora does for their MinGW toolchain.
Sorry, I'm not sure I follow.
So on Fedora, the MinGW toolchain is MinGW32-GCC, and then there's a huge slew of libraries that are the Windows binaries that you could use to link against. If you want, say, SQLite for Windows, then there are a collection of MinGW32-SQLite packages. It sounds like this is kind of analogous to what you're trying to do here. You have a bunch of rump Xen binaries that you want to put together, and possibly libraries that they share, except they are only shared at build time.
And Fedora, you're duplicating all the source packages.
Yeah, so
Yes, it's kind of a mess.
source packages, which are the same thing with the prefix.
Right. I mean, that's another thing that I could try to get through the FTP team.
Yeah, and binaries are arch old as well, because it has a foreign arch inside it, right? It's arch old in the sense
Which solves the
Not arch any.
Yeah.
Yes.
That's jolly good.
It moves the problems elsewhere.
Like you could use xdeb, I presume?
Please don't do that. Speaking of himself. I'm not even sure it works anymore.
Yeah, I mean,
I've used it 2 years ago.
Yeah, that was before we multi-arch.
Yeah.
I'm pretty sure it's working.
so it seems we're not very keen on the IA32 libs-ish kind of, we'll have one thing that knows how to do it all and does it all in the right order. The remaining options are probably that they all involve debs that contain these rump Xen AMD64 libraries and at the end PV kernel images. And the question is, the question we're left with is how do those debs apt-get built, particularly from which source code. And our options that have been considered so far are we should have source debs, we should go apt-get source in Debian rules, or we should duplicate the source code. Does anybody have a fourth option that's less bad? No. Has anybody been writing this down, by the way? No, I see I'm going to have to write it up later. Okay. Well, I guess that's some kind of conclusion. That at least allows me to go to the FTP team and present them with something that looks like a choice.
And using Debian ports was mentioned.
Yes, Debian ports is no good because these deliverables need to be in main. This deliverable here needs to be in well, probably main AMD64 multi-arch. So, you know, unless we're allowed to depend from main into ports, which obviously, right, but that's obviously not. Yeah, I can't see how you could ever get that to work properly.
Well, you just ship an apt-sources.d snippet with your Debian ports key and... I guess it will have to go to non-free or something.
I would point out there is at least one very important precedent for packages using, well, not apt-get source, but apt-get in other ways in their build system, and that is Debian installer. It fetches, rather than using build dependencies to fetch bits of the installer, which would then have to go in debs in some strange way or something. It uses a specialized apt configuration in its own build system in order to fetch the installer components that need to go in the init RDs that it is about to shove into the archive via by hand.
Right, so effectively it uses apt to download debs, not source packages.
UDEBs,
but from the archive.
Yes. So it seems, at least in principle, fairly similar.
Obviously, source packages must be allowed too, then. Great.
Yeah.
Brilliant.
For different reasons. So
I haven't done it in the Debian archive. I've did it in the Ubuntu archive, but I was fetching source packages, and then I would cross-compile them. And then I would use the results again to bootstrap the Android toolchain. But I was explicitly doing apt-get source and then declaring my build using, such that I don't have to duplicate GCC and libc and blah, blah, blah. This way, I essentially was build depending on a source package.
Okay, which source packages contain the apt-get runes so that I can...
I can send you an email.
Okay.
I'll send you an email.
Great. Well, maybe that's actually the answer to my problem. Hooray. Well, thank you all very much. Thank you.